Hello, everybody. Welcome to this new session. And today we're going to look at what our system calls command line argument, environment variables, the execv function, and do some examples. The focus is on the execv function. The execv function allows you to run or execute a system command from your C program. First, what is a system call? A system call is a way for your program to interact with the operating system. Different programs can make requests to the operating system's kernel. And then we have the command line args. Command line arguments allows another program to pass an argument down to a program or a process that's going to be started. The execv function is for that. We have environment variables. We're going to look at that too. And also the examples we're going to look at are very simple and easy to understand. First, let's start with command line arguments. I think this is the way to go. First of all, when you run a program like that, you say in the shell, you type in ls, then you have the ls command that displays something on the screen. What if you want to change the behavior of this command? You can pass in arguments like the -l. We can do similar thing with our own program, a custom program. Let's do that. We pass in the parameters to the main function. The first parameter is the argument count, the number of arguments the program received, and the second parameter is an array of strings. This array is a null terminated array that points to each of the arguments passed down to the program. Great. Then next, we're going to display these arguments int I, then for I is equal to 0, I lesser than argument count I plus plus, we're going to display the arguments. Let's include the standard input output library because we're making use of the printf function. In the terminal, we're going to execute this program, gcc main.c output, and the output will be named program. And let's run this program. And here we call this program with no parameter. The first things that is being displayed is the name of the executable or the path to the executable, the path name. But let's pass in some arguments, let's say A, B, C, D, E, F. And here we have those other arguments displayed, A, B, C, D to F. So this is how you can receive argument uh, from your program. Now, how do we call another function from your program, or how, let's say first, how do we read our environment variables? There's two ways to read environment variables, but let's do the first one. The first one is by adding a third parameter, and the third parameter also is called n. We're going to call it n, and the environment variables are will be received to the main program. For example, one of the uh, when you want to print the env, there is a program for that, a command, the print env. This will display all the environment variable in the current process. So our shell, in the shell, we have the shell, these environment variables displayed, but also we can receive those same environment variables to from the C from our C program. So let's display those environment variable. Well, and I is different than null because this is an array of pointers to strings and it is null terminated. If the env is different than null, then we're going to display a env variable. Let's compile this code and see what happened. Now, when you run this program, the program receives the n variables, then it displays the n variables one by one. Let's execute. I'm going to expand the terminal. Oh, we have a problem, an infinite loop. Yeah, this is because we did not increment the I variable in the loop. So let's do that. I'm going to stop the program first. I plus plus. ECC main.c, the output file will be program. And here it is. We are now able to display the end variables. You can do more research on the end variables, but basically the end array contains for each elements in the array, there is a string, and the string uh, has the name of the environment variable, an equal sign, then the value of the environment variable. So this is what we displayed in from within our program. Another way to receive environment variable, because this way of receiving environment variable is not from the POSIX standard, but the normal way is by declaring what we call an external variable. There is a keyword, extern, then the type of the environment variable, and also the name. An external variable is a variable declared outside any function. So it can be accessed throughout all the program and available from the start to the end of the program throughout the entire lifetime. This environment variable will be set when the program is going to be started, and we're going to have access to this environment variable. But let's include the library where this environment variable, this variable is declared. I think it is from the unit std. Yes. The variable has to have the same name as when the when declared. So we have to have the exact name environ. Now let's display the content of the environment variable or the environment variables we received. As usual, it's just an array of strings and we display each strings one by one. Let's compile the code and run the program. Yes, it is the same result. So this is the normal way of receiving environment variable from your program. This is the fun part. Now we can move on the execv function. Let's say you can kind of run a program from the shell, but what if you want to run a program from your C program? This is possible by using the execv function. I'm going to delete all these things, and yes, here we start by declaring something called char, then command. This will contain the command, and next we have the arguments the starting process have to receive, or the starting program will receive. So we're going to declare a variable called args, an array of strings, and then we might need to declare what we call an environment variable for the all the program that's going to receive, we're going to execute from the main program. Now let's get started. I'm going to create a child program, and this program will be what is going to be called from your from the main program. Let's create a file. The name of the file is child.c, and from this file we have the main function, and the function is going to receive an argument counts and also the arguments, and it will return 0. So for now, we're going to include a standard input output library and print f, so that we knows when the child program start, we knows that we are in the child program. Let's display the environment, the received argument. So we say for, oh, let's declare first an I is equal to 0. For I is equal to 0, I lesser than the argument count I plus plus, then we display the environment, the arguments. Great. And let's compile this code and see what's going to happen. gcc child.c, then we name the output as child program. There is an error, a semicolon missing. Execute again. Great. So now we have the child program, and you can even do an ls to see that we have the child program located in here. So we want to execute this child program from the main program, where we can call the and the execv function. We have to provide in the first place the path name to the program. So since we are in the same directory, we're going to say child path, child program. We can give the absolute path, but also if you want, you can give the path name. This will the related path. So this will depend whether uh, the position of your child program executable um, doesn't change. So the path name, then here the first value for the args that the child program is going to receive should always be the name of the executable. And also the array has to be null terminated. For now, we're not going to pass end to the child program, but if you want, you can. First of all, I'm going to say set up some custom and variables. Let's say my color blue, and the other one will be parent name will be I am the parent. And what else you can pass in as many arguments environment variable as you want, but always make sure that it is a null terminated array. Next, we can call the execv function. Execv function. The first parameter is the path name to the program, so the command. Then the second parameter is the argument that the program is going to receive, and the last argument is the end variables the program is going to receive. So if you don't need to pass in any argument, you can pass in null, but in our case, we want to pass the end. For now, we're going to pass the null. So now the child program isn't going to receive any arguments from the any variable, environment variables from the parent program. I'm going to comment out this line, then we're going to use it later. Great, GCC, the main program, then the output file name will be program. Let's run this and see what happens. Yes, we now have the child program. We executed the child program from the main program. So we gave the correct path name to the child program, and also the args, the first element in the args array should always be the name of the child program, and also a null terminated array. Let's split the screen in two parts. So here we have the child program that receive the argument from the parent, and also we see that we're displaying the variables received from the parent. But for now, we don't have any arguments beside the name of the child program. So let's add something like A, B, and let's say C. These are going to be the name, the arguments passed down to the child program executable. I'm going to compile this code and see what happened. GCC main.c, O option, then program. And here you see that we added some arguments to the args array. That means the executable child program is going to receive the list of these args and going to display it. And here we don't pass any end variable for now. When you execute the program, the main program, execute the child program, and start a new process. So here is how to call an executable or do or run system commands from your C program. It is possible to call other command if you know the path, like the ls command. The ls command is located in the bin folder. So if you want to run the ls command, that also is very easy. Let's just delete all these things. So the ls command is located in the bin folder. You have to give the path to the command. And next here, the command will be bin ls. For now, we don't have any parameter to pass into the ls command, so we keep it that way. Let's run the ls command from our C program, gcc main.c, then the output file name will be program. So the ls command, when executed, have to display the content of the directory. So here it is. Our program can call the ls command and displays the content or list the content of the current directory. For example, in the shell, you can say ls, then you can pass in some options. The same way, you can also pass in some options to your ls command from your C program. For example, we can pass in the -l option and -a option. Or even if you want, you can just pass in LA. Let's execute. So if you type in LI, you see that. Now from the program, we can also do the same thing. I'm going to compile the code main.c, the O option, then the program. Yes, now you see that we execute a program, and after that, the program also executed the ls command. Now that's great. Let's go back to our old example from calling the child program. What if you want to pass in some n variable to the child program? We're going to modify the child program to receive n variable. For that, we declare an external variable, and the external variable should be invariant, must be invariant. And we're going to include the unit std library. So instead of displaying the list of arguments, we're going to display the list of environment variable. So for while the environment I is different than null, we say printf, then we display the environment variable at the index I. So now from the main program, we can increment these variables here and pass in our own custom environment variable to the child program. So n gcc main.c, and the main program output will be yes. Here we see that the child has been executed, and also, oh yeah, the environment variable did not display. This is because we have to recompile the child program, the program called child. So gcc child.c O option, and the output file name will be child program. This will be the executable. If you change the output name, also make sure to change it from the main program because the executable, if it doesn't exist, the exec function won't be able to execute that command. Now let's run the program and see. Oh, we have the same issue uh, because we did not increment it, the I here. I'm going to increment it, so it will be I plus plus. Great. Now we don't have this infinite loop, so GCC child and the output file name, we're going to call it child program. Great. Now that the child executable has been updated, we can run our program. And here it is. The main program passed down to the child program these environment variables, and the child program also has been able to display them. So here is how we pass in environment variable. There is not that much difference between passing args and variables. Now, what is another use case? What happens if the execv function fails to find or to execute that command? What you have to understand about execv function is that if it succeeds, the process in which your main program is running will be replaced. It's going to be replaced by um, the the started process if uh, the program is found and executed successfully. But if not, or if the execute function isn't able to find the child program, it will return a -1. So the main program will know that the command doesn't exist or is is not able to find the command. Let's do an experiment to illustrate that fact. For example, I'm going to, in order to make this example very simple, I'm going to change things a bit. We're not going to pass in environment variables. Yes. There is something more I wanted to add before we move on, is that here we declared our own custom environment variable, but what if you want to pass down to the child the same environment variables that your main program received? This also is possible. Just do an extern char then environment, and instead of passing your custom environment variable, you can pass in the environment variables. Or even if you want, you can you can customize and pass it to your child program. That also is possible. Now let's move on. I'm going to delete some of those things. We don't need the environment for this new example. And let's say that we're not passing args, and here we're just going to have an array of null, null, and the first element of the array will be child program. I'm going to delete this thing called command, and that is much simpler. So the first argument the execv function gonna receive is the array, the command path name, And after that, we have the arguments and we have the end. But for now, we don't want to pass in any end. Now let's um, print this thing. Print main main program start. So program start, and here we're going to pass say program end. So what you're going to notice is that this uh, this is not going to be exec you this one is not going to be executed if the execve function succeed. So let's see in the child program, instead of displaying environment variables, we just going to add in some printf functions. Printf child start, and what else we say, then printf child end. Great. Now in the main program, you see that we displaying program start and program end. And what I said is that if the execve function succeed, the rest of this program is not going to be executed because it will be the process that it starts is will be replacing is going to be replaced the main process in which our program is running in. So gcc main.c, then the output file name will be program. And let's compile the child program also. So that will be gcc child, then child program. Now let's run the program. And as you see the output, you see that program start, child end, because here we were on the in the child program. Here, child start, child end. But after the child program finished executing, we don't see program end. Here in the terminal, you see that it's not appearing. This is because the child program, the process in which the main program is running is being replaced by the child program. And this is an interesting things to know. If the main program failed to find the child program, um, let's say we're going to change, let's say we mistype the name of the program like that, the child program. The execve function won't be able to find or execute. The system command will fail. So that way, the execve will return -1 instead of replacing the process, the current process. So gcc main.c, then program. Let's run it. I'm going to clear the output, the terminal, and here it is. Program start, program end. The execve function failed to find the child program, and and the main process wasn't replaced with any other process. So there is a return value from the execve function. If the execve function returned, that means an error occurred. We can add an if statement or just say let's declare a variable called OK, and OK is equal to execd. If OK is lesser than 0, that means something went wrong, or we don't even have to check for the value of OK, because when the execv function return, if the execv function return, that means we've got a problem. We can simply display something like a message in the standard error output. I'm going to use the printf, the standard error, or just use the p error function command. Yes, I'm going to use the t printf. This will display a formatted output to a file descriptor. So std error file number, file descriptor. Then the format will be the program we weren't able to find. Then the error message command not found. Then after that, we're going to say arg0 because this is the path name of the command. And now we're good. GCC main.c, the output file name will be called program. And when you run the program, you see that, hey, we have program, the child wasn't found. I forgot to add the line break character. So GCC, we're going to see that GCC main.c, the output file will be programmed, and when you execute it, you see that child command not found. What if you rename the child, the program, to the correct name instead of updating it here? So I'm just going to change the name of the executable. So move child program to child. Now here it is. Uh, we have the correct name for the executable, and the main program is expecting the executable to be named child. Instead of recompiling, we do that. It is much faster for now. And here it is. We have child start and child end as what we specified in here. But in the main program, when this part succeeded, we see that the dprintf, there is no error message output. So the return value from the execv function, you can do some search. The return value from this, uh, depending on the value returned by the execv function in case of trouble or error, uh, you can do some if-else statement and determine what is the reason of the problem and display uh, an error message according to that. Thank you and see you soon.